Hello, this is our first macromolecule video, and our primary topic is going to be lipids. But before we introduce that, we want to make sure we understand how do we make the transition between atoms to molecules. Well, we got to bind these molecules together. So what does that look like? This is our two examples. The two reactions I want you to really feel comfortable with are condensation and hydrolysis reactions. Condensation reactions are reducing water. We take a hydroxide group and a hydrogen group. We unite them together and bring them out of the molecule, and then we instead connect those two dangling pieces. Those bonds form with each other, and we get a new united molecule. That is condensation. And we can remember that because we are forming water, like water forms on the glass of a cold drink. The flip side of it is hydrolysis. Lysis means to break, so we are using water to break hydrolysis, and we have this molecule here, but we are going to break it. We're going to take this water, we're going to split it apart, we're going to put the hydroxide on this side, a hydrogen ion on this side, and now we have two different molecules. We have broken it. We have lysed the molecule. And so we need to be familiar with condensation and hydrolysis reactions because those are going to be coming up again and again and again as we do biological molecules. That having been done, let's get to lipids. Good stuff. Fats, oils, waxes, good in storage of energy. We like them. They taste delicious. There are two primary categories, fatty acids and sterols. We're going to talk about fatty acids first, and then we'll get to the sterols. Fatty acids are also called hydrocarbon chains. Each of these little zigzags is a carbon atom, and each of those carbon atoms has 4 bonds, so the 2 bonds we don't see are to hydrogen, so hydrocarbon chains. They're just chains full of hydrogen. That's what we're looking at there. And because they are mostly carbon and hydrogen, this whole section is very hydrophobic, and then they have a little dash of oxygen. So lipids in general, both sterols and fatty acids, are made of carbon, hydrogen, and oxygen, but it's mostly carbon and hydrogen with just a pinch of oxygen for flavor. And so in these fatty acids, these hydrocarbon chains, there are 2 different varieties. There are saturated fatty acids and unsaturated fatty acids. The saturated fatty acids tend to be they have this shape. Their chains are long and straight, and they tend to be solid at room temperature because they can stack and maintain a stable state, a stable structure as the molecules layer on top of each other. That is not the case with the unsaturated fatty acids. This kink that forms bends them so they can't stand on top of each other. There's no stable structure, and so they slide off each other and pool into a liquid when at room temperature. So unless we, take energy away and force them to stop moving, they will pool as a liquid will pool. So at room temperature, that's how that works. So what are they saturated with? Hydrogen. These carbons have 4 bonds each. Every single one of them has 4 bonds. So when they're not bound to each other, they are bound to hydrogen. Every bond is taken with hydrogen that can possibly take hydrogen. Over here, that's not the case. There's 2 carbon that are bound to each other, which means each one of them is bound to 1 hydrogen. And so they could fit another hydrogen in there, but they're not currently doing that. And so they have this bent shape, and that's a response to this double bond. Let's see. There are 2 different types of unsaturated fatty acids. Nope, we've seen that one, sorry. These guys, the cis formation and the trans formation, and that has to do with where the hydrogen is. If it is trans formation, the hydrogen is on opposite sides of the double bond, and if it is the cis formation, the hydrogens are on the same sides of the double bond. What we saw on the other picture with the olive oil, that was the cis formation. This is made by plants all the time, super healthy, great fat. This guy is not made by any plants ever. They are made by chemists and food scientists, and they're harder to break down, so they have less energy because you can't get energy out of them, but they are bad for you because they clog stuff up, and we cannot get rid of them. We cannot get them out of our body. If they get into our body, they stay there. They're bad news. So trans fats are bad, and they happen to be solid at room temperature because they can maintain a straight formation. That means that they can stack and they can maintain a stable structure. So there we go. Those are our fatty acid and hydrocarbon chains. We also have, because there's always more. Although really, this is too long. This is too long for one video. So we're going to break it up. This has been Lipids Part 1. I hope you enjoy it. And I almost forgot. Struggle well.